Yeah.
Hopefully.
Yeah, I was like, I'm like, no, but that'd be so fun. What do I have to play? Those are live ones. Oh, sure.
Well, I think so. They started to do it in tours like in Toronto now. I think the river is very high. Megan and I were like, it should be a car one. I mean, I went talking to her, but I don't really think it's enough. Yeah. Because that might be we are ready to go. What do you want to do? Real life? Real life? Yeah. Someone could have said, but yeah. I mean, the thing is, how I research brands and dogs. Especially marketing and stuff like that. Definitely. I mean, the cool thing about that is everyone is very familiar with it. I saw it totally accepts and understands the value of and sorry, how did you remember something? They literally, they research aspects.
Do you have anything here? Your purse or anything?
It's just so basically.
You better keep it together with you.
Go grab it. Go grab it.
I was actually, I was visiting them in India. And you know, when you visit families, there's a lot of downside. So just like scrolling through Twitter, I saw the abstracts that I wrote up on like the last day of 16 okay, here's the smallest covered it. And it worked out exactly so yeah, over there. Or stuff that my person the same way that we had, I have a colleague, oh, very good. Saw it, knew I know Megan, and would like to lanes have reached out, but like, then to put it back on and see. Yeah. Couple days sessions. I've learned, right? Yeah. Can't leave it to one. Yeah, I mean, it's great. Are you presenting tomorrow? I'm not. Can't wait for your exams. So, I don't know if that's a really but I'll have to go sure. I wouldn't go hopefully ever. I'm fine.
You should go to the life sciences class.
So I was telling you, I couldn't take off my next life, but I do all that. You know, rather than everybody spend the money and
Ask them.
I said, I'm going to get a barcode. So just go into the room and just have like the abstract. You like that? It's good. I need to download it. Like, because I did a challenge.
The same friend was again? Yeah. Okay.
I spent so much time on the last one.
Okay, welcome everyone. Thank you for finding the room. We had to change it because obviously we are oversubscribed, which is a wonderful thing. We have a 1-hour presentation planned and it is being streamed live on YouTube. So we have people from around the world that have asked to connect in. Our speaker, Megan Shaka from Sathletes, is going to be talking tonight for about an hour, and then there's going to be networking. And my colleague, Michael Shuckers, has headed off to go get some material because I think he's going to raffle off some things as well.
Perfect.
So welcome. Hope to see you all tomorrow. We have over 200 registered. So it's coming early. There will be food at 7:30 in the morning. Okay?
Great, thank you.
You know where to make it.
Thank you everyone for coming. This is sort of our first crack at it, but I thought of this idea because when I was at Vancouver or any other conferences, I always had people say, I wish I knew more going into conferences, and I think that's sort of one of the gaps is, knowing what the skill set actually is in sports analytics, and there's so many different variety of backgrounds that come into doing this type of research. So this is not meant to be an exhaustive or in-depth workshop, but just something to get you to start thinking about what's out there in sports tech. So I'm going to start off with an introduction. And we have the lovely Namina from Wharton. She's going to go through a specific example. So as a 4th-year student, she can really be in some of your shoes and show you how she uses coding to help her do better research in hockey. And then Sherry's going to wrap it up with to talk about innovation in sports tech, what's happening in Canada and North America, and what other opportunities there are, not just in coding or computer science, but also in all type of sports tech. So whether it's VR, AR, fan engagement, there's so much out there for young people or people that are interested in sports. So I just want to touch on everything so we weren't just focused on one area. And then also, the lovely people at Adidas are giving us 3 prize packs for tonight. So we're doing a little bit of a quiz, Ottawa Senators quiz, because they're still in the playoffs. We like that. So we'll finish with that. So hopefully all good things. And I think if there's a place you want to stop me, especially if you want to talk about me or my experience, stop me early so we can kind of get to that and ask those type of questions instead of leaving them all to the end, because I think we'll more than fill up the hour. So a little bit of background, I'm sure some of you know this is a JSON file. Scares a lot of people who aren't in computer science or engineering. It's not actually that scary, it's just some eventing of different sports statistics that we're taking of hockey. You can see here we have Sidney Crosby as a shot recovery 5-on-5. And this is what a data pipeline would look for us and could scare the average fan, but actually provides a lot of interesting information. So I've taken this and made a little visualization. This is actually 3 or 4 years ago. I just sort of threw this together to show people that, you don't just have to watch hockey, you can actually engage with it on a second screen. So this is about, I think, 30 seconds to a minute. But you can see here's shots, zone times, puck possession, entries, exits, and you can watch this in real time as the game's going on to understand on a second screen if you're out, or when you want more information on what's actually happening during the game, who's dominant and why, and maybe even what type of metrics might be predictive of better or worse play. Just sort of an interesting visualization that I've taken the data source that we saw before and mapped onto some visualizations that an everyday fan could understand. So sometimes I think they say that it's not hard to do hard things, it's hard to make hard things simplistic. And for me, there's a lot of value in understanding the game even at the smallest level. And I think too, as we know, Canada's extremely diverse. A lot of people, come from overseas, are interested in soccer and a lot of other sports. And we like to say that hockey is an amazing sport. You just kind of have to understand it and get into it. And it's just getting new fans into the game. So whether you're in Toronto or Ottawa or Vancouver, I think there's a lot of fans we can capture by, being more interesting and more innovative with how we use data to reach fans. So the second visualization is actually from where I met Sherry, and this is Professor Bradish will be speaking about innovation at the end of the presentation, but I was doing a competition which I was one of the winners for Rogers. It was called the Next Big Idea in Sports, and I wanted to give even more understanding of different plays and what various attributes made good hockey players versus bad hockey players. What type of plays were made under pressure, who maybe failed in certain scenarios, so who missed their coverage. Why is that defenseman better than another one? All those type of questions. Why is his shot attempt maybe a higher probability than most? Is the goalie moving? Is he out of place? Is it a one-timer? Is it a weak side pass? The interesting thing about that shot, which is why we chose that scenario, it was actually, didn't even hit the net, so it wouldn't be reported as a shot on goal, but was one of the higher probabilities for scoring based on all the parameters that we calculated. So for us and as athletes, we like to not only use data on the back end, but also on the front end to help connect fans, or whether it's coaches, players, agents, to our actual data source. And obviously doing higher level modeling, which Namita will get into in more detail. But for me, it was not only building a tech company, but also a consumer-facing and fan engagement tools. Does anyone have any questions on Stathletes or startups or collecting data, that process? Sure.
How many people do you have collecting data on a single game?
Single game, we probably have like 10 assigned, 10 people assigned, but each night we probably have 30 to 40 at least. So it's quite the operational puzzle.
And the stats that you showed on the screen, those are typical of the ones that you record each game that you mark up on?
Well, I just cherry picked what I thought was interesting. Okay. Yeah. Because as you know, there's good and bad with data, and that you can almost overwhelm people, right? And I think that's the same with research. It's great to have a ton of data, but at the end of the day, you want to use what's pertinent to your thesis. So I think that's our biggest problem too sometimes in hockey, is we tend to look at a really big question instead of focusing in on what the actual most helpful data set is. So for that specific project, I just wanted to really relate it to an average fan. And I think that's sometimes hard depending upon what you do. So I just wanted to show successes and failures with what I had.
Okay.
Yeah.
How do you assess the reliability and validity of the stats that are collected, given that rink bias is such a thing?
As in, like, there's people collecting in rink, like in the arena?
Just that, it can be really messy to understand what a shot on goal is, or what, a controlled zone entry is. So how do you take the people that are collecting that in real time, check it?
So we don't collect everything in real time. We only collect like a subset of events in real time, and we audit everything. And everything's very clearly defined, tag to video. So we go through, and if it's not 95% accurate, we actually will remove the whole data set and have it re-recorded. Like shot attempts is pretty easy. Things like location. So at the start, we had people that would mark someone shooting from when they started a release to when they ended. And we decided to mark it exactly where it left the stick. And that was just, it's going to be that regardless of what anyone's technique is. So little things like that sure, maybe there's different releases and that will change, but we know it's at the exact point where someone sees it leave the stick. So, I mean, that's taken us 4 or 5 years now to refine a few things, like a control. I mean, there's going to be some variation, but in general, we can queue up any sort of, like we could show you all the controlled exits, and if you didn't like one, we could untake it. Any other questions? Okay, so now Namita is going to go through an exact example, more specific into the coding that I know you all came for, and talk a little bit more about R and Python and different languages too.
Hey everyone, so thank you so much, Megan. So yeah, I'm an undergrad student at Wharton, just flew up from Philadelphia today, so I'm very tired, so stop me if I'm rambling. But we're going to go through a specific example of how I went through all the stages of thinking like, oh, this is an interesting question. I want to learn more about this. Let me write some code to help me really understand what's going on. And then the end conclusion. And before we even really get into it, what I want to make sure that everyone understands is that it's not important that you sort of memorize or write down every line of the code. And in fact, we will make an, probably send out the slides, and I'll tweet out the code and data as well at some point. But what's really important is that you guys just understand at a high level kind of what are the steps that you take to do research like this. and the issues that you run into and how you overcome them. So first of all, I'm going to go through this example in R. Definitely not the only language that you have to use if you're doing analytics in hockey, but it's definitely one of the most helpful languages. I'm also very partial to Python, so I just put that up there. And basically, if you're going into it, having never done anything before, you download R, you download R Studio, which is the interface that allows you to code and save files and stuff like that. And then any other functionality that's not in base R, you can install a package, and that's very easy to do. It's just that one line. And this is what R Studio looks like. And so you like write the code up there, and the console is where you actually run the lines and see what the output is. This is where you make pretty graphics, which is my favorite part. And then that tells you kind of like what your data sets are that are loaded in and packages and stuff like that. Okay. So first of all, so like I said, this is a specific example, and basically I've been working on it over the course of like the last week, so it's very recent. So first of all, when you want to do a project, you have to decide what's interesting to research. So my favorite thing is the draft, so I always ask myself questions about the draft and try to figure those out. But actually, this isn't even that. This is going to look at the concentration of goal scoring in each team. And I'll talk more about, why I decided to look at that for this. But basically, it's whatever that interests you, and, you might just think this is like corny or whatever, but even if it's a topic that you think that everyone has done amazingly and better than everyone else, and, there's maybe an expert in the field who knows everything there is to know about it, people don't have 1 million hours in a day to do everything that you might think is interesting. So chances are, if you try to work on a project, even if it's as simple as taking someone else's model and updating the data, maybe adding a variable or two, that is important and that is relevant. So I just wanted to make that very clear. And then before you can even write code, you have to get the data. So ideally, we all learn web scraping perfectly, and then, any website, we can take all the data and it's beautiful and amazing. But the point that I wanted to make here is that there are actually other tools that are very helpful in scraping and compiling data. And so sometimes you'll have websites like Corsica where you can just run a query and it outputs a CSV file, which is what you end up loading into R. But other times, you can use a free scraping tool. I'm very partial to ParseHub, so write that down. It's like a great tool. And that's just like pointing and clicking at the data that you want to scrape. And as long as the websites are similarly structured, you can scrape a ton, and it's free and it's easy. And sometimes it is as simple as copying and pasting a web page into Excel. You can do this with Hockey Reference, which is a great website. If you just copy and paste a table into Excel and mess around with it a little bit, there's your data set. So that's one way to make this very, easier than it might seem. And then, so again, like I said, the topic I'm going to talk about is analyzing the concentration of goal scoring in teams and seeing if it's important or relevant. So Alex, who is a fellow writer at Hockey Graphs with me, talked at the Vancouver Hockey Analytics Conference about basically whether you want to have a team strong and weak links, so a very wide variance of talent distribution, or do you want there to be no weak links and everyone's pretty good? And so definitely look into his talk, it's very interesting. But that reminded me of Lorenz curves, which are frequently used in economics. And what they do is they try to measure inequality or concentration, and they're most frequently used to measure income inequality. And we're looking at basically cumulative variables here. So this is cumulative percentage of a population, and this for econ would be cumulative percentage income. And then so basically, if everything is totally equal, you'll have a straight line going from 0 to 100%, because what it's saying is, okay, 50% of people make 50% of the income, in the country, all the way up to 100%. But as we know, most countries are not like that. So here, this like curve B, you can see that if you look at the 50% mark, you're looking at maybe like 10%. So that would be like 50% of the population makes 10% of the income. And so this is how you can sort of garner insights as to how spread out something is. And so like they're very popular for econ, but you can apply this idea to basically any topic that you want, right? So as long as you want to look at a distribution or concentration of something, it's relevant. So we can look at it for hockey. So I said, okay, I want to use this and I want to measure the concentration of goals for every team. And I want to see maybe how that relates to team quality. So if goal scoring is very highly concentrated in a few players and the rest of them don't really contribute that much, does that give us any sort of indication as to like team quality, or does it not matter? Or just what does this distribution look like? So you start with a very open-ended question. And then I scraped data from Hockey Reference, and again, that was using that online scraping tool that you can literally copy and paste as well, and saved it as a CSV file in Excel. And this, is a snapshot of the file, the data that I had. So, for every team, I had player, the number of goals they scored. I also got some other stuff like time on ice and position, because that does end up being relevant for various reasons that I'll get into. And also point shares is the value metric that Hockey Reference has that I think is pretty decent. So I have this data, and I want to make basically Lorenz curves for each team, and then calculate Gini coefficients, which are a measure of the concentration. Can you go back one slide? So the Gini coefficient, just so when we get into the code, this is not confusing. It's basically, I think it's A over A plus B, where B is the area over here and A is the area over here. So if everything is completely 100% concentrated, then that would be 1. And if everything is completely 100% equal and B and A are equivalent, then that ends up being 0. It's kind of easier to see when we move forward, but basically just know that the coefficient, that's like the one number that measures the concentration and inequality, is a number that goes from 0 to 1, with 0 being perfect equality and 1 being like perfect inequality. And yeah, so this is the code, and again, I just wanted to emphasize that you don't have to memorize or write down any of this. Again, we'll make it available, but I just wanted to talk about the broader process of how I decided to write it and order it and everything. So, the first line is reading the CSV file in, so that's a good start. And then I want to find out this coefficient of inequality, the Gini coefficient for each team. So I decided to write a function that would allow me to do that. And so the idea was, if I just input like Gini parentheses any team name, that it would tell me how concentrated goal scoring is. So the first part of the first part in that first set of brackets is all about just sorting the data and getting the players and the team that I want. So you see that I subset on team. I exclude goalies because that's not really that relevant. And also I had more info on the previous slide about this. Can we go back one? Yeah. So the problem with this that you might run into is, so what constitutes a member of the population for a team? What if some guy is just called up for 2 games because of an injury and he goes back down and he doesn't score any goals? That would make your goal scoring team artificially concentrated. So to fix that problem, I decided to take the top 21 skaters, 23 to a roster and 2 of them are goalies. So I just picked 21. You could conceivably pick other numbers. But it's always important to, before you really get into it, to try to, at a high level, decide if you're going to run into any problems. The way that I always frame it is what if someone didn't like me and they read this work, what would they try to fight me on? So, this is the thing that I thought of right away. And that's what, if we go back to the code, and that's why you can see in the third line of the function, I say, okay, take the observations 1 through 21 based on time on ice. So I'll say we'll take this top 21 skaters that spent the most time on ice for each team. And then, we do ordering by goals, and then we make 2 extra columns. One of them is like the cumulative player, so that's like the percentile of the player from 0 to 100%. And then the cumulative goals, so that's the percentile of the goals scored from 0 to 100%. And then this area calculation is like a bit annoying and like, throwback to calculus, because you're basically calculating the area under a curve. But that helps you figure out the Gini coefficient. And then I say like return the coefficient. So like I said, if you define this function and then you put in any team name into that function, it'll tell you what the coefficient of inequality is for that team. And is there anything else that I wanted to say about this? But yeah, just like very much, I broke this up into 3 parts because those were legitimately just 3 stages in my mind that I went through. And it's very important to kind of break up that one big problem into smaller ones. Because if I had just decided like, okay, I'm going to write this function, that would have seemed very overwhelming. But once you break it up, even though it's like a lot of text and code and whatever, it seems hopefully less overwhelming. And then finally, we get the results. So for, the last bit of code is just like compiling the results for each team with the coefficient. And again, like I said, a bigger coefficient means like more concentration in terms of goal scoring. And so I've just literally copied and pasted the output, which is why it doesn't look as pretty as it could. But as you can see here, like Tampa had the highest concentration, and Arizona had the lowest, and then that's where you kind of eyeball it and say like, does this make some amount of sense to me? And if you have watched Tampa at all, you know that it was basically the Nikita Kucherov show this year, so it does make sense because he scored 40 goals and very few other people scored many goals, so it makes sense that Tampa would have the highest concentration, and then other teams like Arizona, well, I'll say the Wild had good players across the board. And so, but already when you're looking at this table, you might be trying to find a pattern of like, oh, do teams with really high concentrations of goal scoring do well or do they do badly? And it's like, it's pretty hard to see a pattern. Like the Caps and Pens are like right in the middle. So, and then if we go to the next slide where I have the results in graph form, and I colored light blue as playoff teams. I was too lazy to get like points percentage or anything. But basically, there's not much of a pattern. Conceivably, this, concentration of goal scoring might not matter quite as much as like who is scoring your goals. But the last point I wanted to make about that is like, null results are interesting results. Even if you do all this work and you scrape your data and you write beautiful code and it turns out that nothing you studied makes any impact that you can see onto the issue that you're trying to look at, that's fine and that's interesting. And if you share that, that allows people to either say like, okay, rather than look at this field, I'll look at another field, or even say like, oh, I think that you missed something. What if you try this? So I just want to make the point that like, as long as you do good work, even if the result isn't what you want it to be, it's still important and it still absolutely should be shared. So before I pass it off to Sherry, I'll take any questions.
I thought about reducing the number of skaters to make instead of 21 and reduce it down by the top, say, 2 lines. So the top 2 lines of most ice time.
Sure. Yeah, I was already thinking about like maybe excluding, defensemen, although I mean that runs into issues when you have players like Erik Karlsson. But the cool thing about the function, if we could go back to that, is that one more slide. Is that when you is that when you're writing this, it's so easy to change that because all you have to do is go up to that 3rd line of the function where it says 1 to 21 and just do like 1 to 10 or 1 to 6 or whatever you want it to be.
Exclude defensemen too if you want it.
Yeah.
position either of both. That's
Yeah, no, I definitely think that's a good idea. Maybe looking at the concentration of scoring in forwards versus D-men, stuff like that. I think that would totally be interesting. The reason that I use this example is because, people always, whenever I present this topic, people always say like, oh, I want to look at the concentration of this or that or whatever. And, the point I want to make is like, you absolutely can do that. And I think there would be some really interesting insights from that. Any other questions?
When you go to scrape your data, like you obviously had a very clear goal in mind.
Mm-hmm.
I guess how do you choose whether you're going to take everything, whether you're taking a subset of the data available?
Okay. Yeah.
Like how do you make that decision?
So with this, I had a very clear goal in mind, but with my draft research that I do, I did not have a very clear goal in mind. Take everything. So, because the issue that I ran into when I would scrape, prospects, is I would start being like, okay, I want what they did in juniors, so I'll scrape that. And then, I would go back a week later and be like, okay, birthday effects are a real thing. I want their birthdays. And then I would have to re-scrape that and sort of concatenate and do all this fun stuff. So, don't be like me and just start with like anything that could possibly be remotely relevant is worth scraping and having, as long as it doesn't make your file like insanely hard to work with. Although then, you can use SQL and other tools. But definitely, it's so much easier to scrape it right the first time. Any other questions? All right, cool. I'll pass it on to Sherry, who's going to talk about advances and opportunities in sports.
Thanks. Thanks, Megan. My name is Sherry Bradish, and I'm a professor at the Ted Rogers School of Management in Toronto. I don't know how many of you are from Ontario, but I was at Brock before that. And so I met Megan in 2015, which is pretty crazy. So thank you to organizers for squeezing me in. So Megan and I intersected on a project that we did with Rogers, and we continue to work together formally and informally. So I am just going to kind of go a few more feedback from the specifics of your conversation and really just integrate some of the broader implications and conversations we're having around sport innovation. So in 2015, and I'm sure you're all familiar with the growth, and I'm going to talk about this in terms of a more sport business trend in general, accelerators and incubators in North America and across the globe. In 2015, it was a really new field. We launched our project in February of 2015, and the only really dive into sport innovation as in terms of an incubated project was Harvard had done a Dean's Challenge around sport, but it wasn't necessarily an open call. It was for graduates and alumni of Harvard. So in February 2015, we launched. The Dodgers Accelerator came out a couple of months later, just to give you a frame of reference. And just a little bit about this, we looked at a number of verticals. Just as some numbers, we had 78 teams in startup supply from Canada, the coast to coast, which was very comparable with the Dodgers numbers at the time, so it was interesting. So we have pivoted a little bit since then and taken the project into the School of Management and are working on the next iteration of how do we create a sustainable, open, networked space and community. But Megan thought a couple of trends might be interesting to share, how it links to innovation, technology, and analytics in particular. So you'll see varying conversations around this, but this is where we see the most innovation and technology coming from the startup world, which is how we intersected with Stathletes. E-gaming is not here, but of course we know that the growth curve there is incremental. So we had 7 verticals that we dealt with, and we see engaging and launching in the sports space. Athlete and team performance, including wearable technology, around sport media, digital content, fan experience, engagement, marketing in particular, some personalized social tools for sports content, analytics, business management, and then sport and social innovation. And throughout North America, the, at this point, most heavily engaged kind of sport vertical or startup in sport innovation still is migrates towards athlete team performance, wearables, sports psychology tools, et cetera, et cetera. So hence we're starting to do some work with York and U of T with their kinesiology departments. So those are the sport verticals where you see some work on our end, linking with smart startups and analytical people to really look at what are the challenges from a managerial business development perspective we can help them with, and then as well, how do we integrate these into making the industry better? So that's kind of the verticals. And I think there's just one more, quick. Yeah. So the other thing I said to Megan, I just thought we could share is just really just an overview. There's a lot written about where innovation and technology is going, but this seems to be where the conversations are happening today. And we know, as I said, esports is here now, as it should be. And just about the integration, virtual reality, augmented reality, how sports science really used to take a lead at the beginning, in particular at some of these incubated ideas and conversations, esports accelerators, innovation hubs, intersection of the medias, and then the teams are playing increasingly interesting roles in sport business around innovation technology. So that's just really 10,000 feet perspective from business schools and some of the projects that we're doing with the sport innovation, and we're working with some of the teams in Toronto as well. Thank you. I don't know if anybody has any questions or
Any questions? Go to Sherry and academia. So it's sort of nice. You've had a student, you've had industry, you've had academia. And I think to both the organizers too, thank you so much for everyone that says that there's not smart women that can come out and give you all sorts of information is making excuses. So I appreciate everyone for showing up, and just everyone a round of applause for. So if you want to do, the top 10 on every team, you want their Gini coefficients, you can do it. And so now I just have some Adidas questions. So they're giving me 3 outfits. If you're not a female, you don't have to have a sports bra. You can skip that. But my dad is like the hockey trivia person, so he's wrote some in particular on the Senators. So for the first Adidas prize pack, what Ottawa Senators team captain liked to wear a turtleneck under his sweater? Yes. Okay, I'll have to try a harder one. So he made them themed too. So in the early years of the Ottawa Senators, early 1900s, the Ottawa fans had one custom that they would do when they were not happy with an opposition player. They did this when Fred Cyclone Taylor came back for his first visit to Ottawa after leaving Ottawa the previous year and signing with the Renfrew Creamery Kings. Hint, it left everyone sour. What would the fans do?
Pour some milk on them?
Close.
Throw lemons on the ice.
Yeah, they throw lemons at the players. Perfect. Okay, so for the last one, in keeping with nicknames and Cyclone Taylor, he too had other nicknames. Can you name another nickname from another team he played on? I don't know. I don't have that online. Can you think of another one? He was on Portage La Prairie and in Michigan. How about what Junior B team in Ontario is called the Cyclones after Fred Cyclone Taylor? Where are they? Who said that? Perfect. Absolutely. So there's a 30. So thank you, everyone. I think you're doing a draw as well, correct?
Yeah, so so first off, we've got a little thank you for Megan for doing that. So let's give her another round of applause. And so the St. Lawrence women's hockey team donated a couple of things for us. And so I've got stars. Well, we have some shorts from the St. Lawrence women's team and Maya Pelletier. Maya, you win those. And we've got a hat for Jim Moronic.
Yeah, that's me.
Jim, come on down.
Can I trade it in for a beer?
No, absolutely not.
I will wear it with great pleasure.
Oh, indeed. And lastly, we've got a shirt. Marcus Bordage? Marcus, I don't know if it'll fit, but there you go.
Thank you.
We're getting the names.
So I want to do a little bit of networking here. So before everybody leaves, what I want you to do is turn to the person on your left and introduce yourself. Yeah, I guess that's your left. And say hi and introduce yourself, and then turn back the other way and introduce yourself.
All right.
So you can meet some folks.